We had finished this slide. Good morning, all of you.
Good morning, ma'am.
What do you see over here? What can you make out? Because we
Ball.
are doing the chapter friction. Yes, what is it?
Ball.
Ball. Fine. Ball is on what?
Grass.
Grass. Fine. Now, if I ask you a question, a ball on a grass and ball on a ground. Again, I repeat, ball on a grass and ball on a ground. Which one will have more friction? If I roll a ball, again I explain, if I roll a ball on a smooth surface that is ground and I roll a ball on a rough surface that is grass, when will the ball stop? Will it stop faster on ground or on grass?
Grass.
Exactly. Why? Because it is a rough surface. You understood? More the
Yes.
surface is rough, the friction is more. This is what we have learned at the early of when at the beginning of the chapter. This is what we learned that more the roughness of the surface, more will be the friction, right? So if more will be friction, the object will come to a halt. The object will come to a stop. Same thing happens over here. For example, you know direction over here. This is a box. We are pushing a box. So force is applied on the box. So the box is moving here. But we always know that the friction is always on the opposite direction. So it's not allowing the box to move forward. So friction is same over here. What do you make out of this picture? There's so many cyclists. What are they doing? What are they doing, Vita?
Pedaling the cycle.
They're pedaling the cycle. Now, if you stop pedaling, what will happen?
After sometimes it will stop.
After some time, it will stop. Why? Because it is not getting the energy in the means of force, in the means of pedal. So, what is the energy of the cycle? It is the pedaling. If you don't give energy to the cycle by the means of pedaling, after some time the cycle will stop, isn't it?
Yes.
Okay. Now we'll see what are the factors which are affecting friction. Please read with
Factors affecting friction. Friction depends upon two factors. They are nature of the surfaces in contact, the smoothness of the surfaces, how hard the surfaces press together. Friction is less on a smooth surface.
Fine. So what we learn from here that friction always is based on two factors. First is just now we talked about the nature of the surfaces in contact. Okay? So how the surfaces are, whether the surfaces are smooth or rough, that's one thing. And the second one is, are you applying force on the surface or you're just gliding past? You understand what I'm trying to say? How hard the surface is pressed together. That means the cycle tire and the ground, how hard, how close they are pressing to each other, or are they sliding it? For example, if I'm rolling the ball onto the ground, it is sliding. It's not sliding, rather, it is rolling. It is not at one position, right? But if I'm standing on the floor, I'm at one position. I'm pressing it too much at one place. What do you say? But if I'm pedaling the bicycle, I'm applying the force, but not at one place because my cycle tube, the tire, is moving, right? It is not at one place, it is moving. Do you understand? But if I'm standing on the floor, on my feet, so I'm applying a lot of force which is very much in contact with the ground. My feet is very much contact with the ground, isn't it? So the surface of the ground and my feet are in very much contact and the force is hard over there. But whereas when you are riding a bicycle, when you are skating, when you are skiing, it is not at one place, it is moving. Did you understand the difference?
Yes, ma'am.
Yes, okay. We always know that friction is less on a smooth surface, and that's why we slip. Let's talk about if it's a tile floor and you run with a speed on a tiled floor, which is very smooth, it's sparkling, it's polished, you will fall, you will slip. Because you cannot control the friction is minimum. There's no grip. If there is a tile floor, there's no grip. Okay, now let's talk about your shoes. If you just see the under surface of a shoe, it has got grooves. You know, these are called as grooves. See the under surface of a shoe, it's got those cuts. Have you observed that? Have you ever observed this? It has
Yes.
got cuts under. Why? Why it has got beta? If it is flat like this, do you think will you be able to walk? There's no grip. It will slip. Your slippers will slip. But when it has got these grooves, it is increasing the friction because it is a rough surface. You understand? It is increasing the friction so that you can have a grip on the floor and you will not slip. Understood, all of you?
Yes, ma'am.
Now, this is. Will you be able to help me out in this matter, this activity? One activity is this one, and this is the second activity. Will you be able to explain? Can you explain, Vita? You can try. If not, then I'm there. Hello?
Means friction is less on a smooth surface.
Yes. No, not that way. What is this activity shown? Below that, there's one activity, isn't it? This activity I want you to explain. This one.
Yes.
What is it? Should I help you one thing? Let's say this is an
Yes.
inclined plane. Can you see this? This is slant. It is an inclined plane. Got it? Yes, this is an inclined plane. And the object is rolling from top. There is the object and it is rolling down. That's why it is kept in dotted line. So it is going down, it will go down, it will go down. And this is a straight plane. Now it will move. See, it is moving. And then it comes to a stop. Right? The energy which it gained while sliding, the energy which it gains will be converted to the distance it travels. You understand?
Yes.
Yes? Okay. Another question to you. Now, this is the object. You can see this is the size of the object. This is the object I'm talking about. Now, if I make this object a bit big, this much I make the object. Now tell me, the object will come here The same position or it will take another position? How much distance will it travel if the object is bigger?
Means
Hello?
it will be not in this position.
Where will it be better? Before or after?
Before.
Exactly, before. Because the surface area is more. You know that, right? Surface area also
Yes.
works in friction. More the surface area, less will be the friction. Okay? And if it is smaller, this much, smaller. If it is this much, then wherever it go, it will land over here, maybe. You got my point now?
Yes.
Bigger, before, smaller, after.
Yes.
Now you have understood, okay? Good.
Yes.
What is written over here? Friction is more on a rough surface, right? The same activity, but the what you got as the surface over here. This surface is rough. Okay, so friction is more on a rough surface. We know that already, isn't it?
Yes.
That was a smooth surface. This was a rough surface.
Yes.
Please read.
Friction is more if the surfaces are pressed harder. Friction is less if the surfaces are not pressed harder.
Okay, you can see over here. This is a big box, right? One on the left hand side. This one left, and this is right. Here is friction is more because the surface area is more. It is pressing harder, that's why, because the surface area is more. Here, the surface area is less. So, as compared to left, the right one has got less friction, right? Right,
Yes.
beta? Okay. So, I'm just
Yes.
showing all these examples so that you will understand how the friction is working. Let's see the cause of friction. Why frictions are created? Yes, beta.
Friction is caused due to the interlocking of irregularities between the two surfaces in contact. Smooth surfaces have minute irregularities,
It is minute. Read it again.
minute irregularities between the two surfaces. Rough
See, the
surfaces.
pronunciation changes according to the context. Now here, what you said was right. MINUT is minute, right? You agree with me?
Yes.
MINUT is minute. But here, contextually, that minute will not fit. So the pronunciation changes. It becomes minute. Okay?
Okay, ma'am.
Okay.
Rough surfaces have larger irregularities between the two surfaces. So force of friction is more if the surfaces are rough.
So we almost know that, right? Why force of friction is more on the rough surface. Now let's talk about the interlocking of irregularities. For example, one surface is the ground surface. So it has got some bumps, yes, it has got some holes, again it has got some bumps, again it's got some holes. This is the surface. Similarly, the one which is in contact with the surface, that is ground surface, will also have the same bumps and dents, right? And that they interlock. Wherever there are cavities, those bumps of the other surface will interlock, and that's how it moves onto the surface. You understood?
Yes.
Yes. So this is called as interlocking of irregularities between the two surfaces in contact. It's you must have seen this jigsaw puzzle. Now we have got two hands, isn't it? When you interlock your fingers, what we do? We put our fingers in between those cavities, between the gaps of the fingers, isn't it? What we do? We keep our fingers interlocked. How come? Because there are gaps between the fingers, and we place the other fingers in those gaps and we interlock our hand. What do you say? The same thing happens on the surfaces which are in contact with each other. Understood, better? This is called as interlocking. What it is called? Interlocking. Okay?
Okay, ma'am. Ma'am, what is minute?
Very little, little, small. Got it?
Yes.
So very little irregularities. So smooth surfaces have little irregularities, whereas rough surfaces have got more. So where will the friction beta? Rough surfaces. As simple as that, isn't it? I told you already, rough surfaces have got more friction.
Yes.
Can you see this? So this is irregularities. You saw the surface? Hello?
Yes, ma'am.
So when I lock it, it gets patched up, isn't it? This
Yes.
interlocking of the rough surface. This is how, what I want to show you. Now you understood?
Yes.
This causes friction. Got it? This is the place which causes friction. We will see the types of friction. Read it.
There are three main types of friction. They are static friction, sliding friction, and rolling friction. Static friction is the friction exerted on a object at rest. Sliding friction is the friction exerted when an object slides over surface. Rolling friction is the friction exerted when an object rolls over a surface. Sliding friction is slightly less than static friction. Rolling friction is less than sliding friction and static friction.
Right. As the name suggests, static means it is at one place, right? Stationary. Static is stationary. From the word S-A-S-T-A-T. Static, stationary. Both looks alike. So, static friction is what? Is a friction when the object is not moving. It is not moving. That is called a static friction. For example, I'm standing on a ground. I'm not moving. So I've got a friction with the ground and my feet, or the sandal that I'm wearing, or the boot that I'm wearing, or the chappal that I'm wearing. That is having a static friction with the ground. What do you say? Hello, what do you say? Hello, did you understand better? Girls, did you understand? Hello, hello, hello. Can you hear me better?
Yes, ma'am.
Okay. So static friction is what? Is the object when the object is at rest. So I'm standing on ground. That means that is a static friction. I'm not moving. Now we come to sliding friction. When an object is sliding over a surface, for example, you're sliding on a slide. You're sliding on a slide. Or uh, the skate, ice skiing, ice skating, all these are sliding objects. Rolling friction. That is ball. The ball is rolling over surface. So that is a rolling friction. When a friction is due to sliding, remember that it is less than the static friction. Similarly, the rolling friction will be less than the sliding friction, which is less than the static friction. So which friction is more? The static friction is the most, right? So static friction is the maximum, followed by sliding friction, and then the rolling friction. Have you understood?
Yes.
So we'll see one by one. What is static friction? Start with it.
Static friction. Suppose your little brother gets into a box and wants you to move him. He too he is too heavy to lift. You try to push the box and it doesn't move. What type of ac-
Acceleration,
acceleration
acceleration,
acceleration
acceleration.
acceleration does it have? Zero acceleration.
Exactly. What is this static friction, beta? This static friction. Now, your brother is in the box, in the carton, okay? That cardboard, big cardboard box. So, while playing, he gets into the box and he doesn't want to come out. And moreover, you want to push the box to a corner. It's because it is in the center of the room, you don't want it. You want it to push it. You want your brother to come out, but he doesn't want to come. He doesn't want to come out. What you will do? You have to push the box to a corner, isn't it? You understand?
Yes.
Yes. Okay, and you want to take him out, you want to lift him out, but he's too heavy, so you cannot lift him out. So you're pushing the box. Do you think the box will move? When you push the box, because your brother is too heavy, can you push the box? You
No.
cannot push the box. So there's no speed. This is called static friction because it is not moving. You're trying to push, but it is not. Do you understand? Hello?
Yes, ma'am.
Yes. Okay. Fine. Why it is not moving? Due to friction. Because the your brother in the box and the force, the friction with the box which is touching the ground. That friction is more. So the box is not moving. Box is opposing, the friction is opposing the force that you are applying onto the box. And the box does not move. So which force is more? The friction force is more. Do you understand?
Yes. Remember Newton's second law of motion. If the acceleration is zero, the net force is zero. Therefore, because you can't move it, another force is being applied to cancel out your force. The opposing force is
That.
friction. That opposing force is friction caused by the microwells between the bottom of the box and the floor. This type of friction is called static friction.
Did you understand what is happening when you're trying to push the
Yes.
box? Yes. So that box also has, this is the box, right? This also has those dents and all those things. Got my point? With the floor, with the ground floor, right? So this opposing force, which is friction, why friction is caused by the macro wells, that means the dents and the grooves, where it is observed between the bottom of the box and the floor. This is more. So it is static friction. It is not, so the box does not move. Understood? And it
Yes.
becomes zero. The net force becomes zero. When the net force becomes zero, obviously the box will not move. The force which I am applying and the friction force which the box is applying or the ground is applying to the force that I am pushing the box as, it nullifies. It becomes zero, and hence the box does not move. My force and the friction force is equal, so it does not move. Understand, beta?
Yes.
Understand? Okay. See, the baby is coming out of the box. Yes, please read.
Static friction is the friction between two surfaces that are not moving past each other. In this case, your push is not large enough to break the microwells and the box remains stuck to the floor.
Got it now? Now
Yes.
you are pushing, but your push is not that big, is not that large, so that those irregularities that is observed between the ground surface and the cards for surface is not that much. So box is stuck to the floor. It is not sliding. You got my point? Because the
Yes,
force that
ma'am.
you're giving is not that much that it will break those microvels. So box remains at the rest. Now we come to sliding friction.
Sliding friction. To help you move your little brother, you decide to ask a friend. You both push and slowly but not easily. The box starts to slide across the floor. When you stop pushing, it quickly stops moving. Sliding the box is difficult and there is still resistance. Although you have overcome the microwells, there is still a sliding friction occurring.
Now, did you understand what's the difference between the static friction and the sliding friction?
Yes,
When you were doing alone, the box did not move. Now you still want to move the box. So you will ask help of your brother, sister, or your friend, right? Hello? Right or
yes,
wrong? Then you start pushing the box. When you both are pushing the box start moving slowly. But still there is a resistance. See, because of the weight of the your brother inside the your little brother inside the box. So it is resisting. It's not moving easily. There's a resistance from the box. But it starts to slide. Okay? It starts to slide. And when you stop pushing, the box also stops moving. You agree?
yes,
Yes? Okay. Now I wonder whether have you ever done that? When you slide a box, when you slide a table, you really have to push hard. You have to apply a lot of force. Yes or no? It is very
yes,
difficult because the box is saying no, the table is saying no, but still we are pushing it. So it is quite difficult. Now, why is it sliding? Because those microvels, those grooves and dents and those cavities, those bumps, we have overcome. So the body is moving. If we don't overcome, the body will not move. Remember that. We have overcome those microvels, but still that sliding friction. Okay, the sliding friction is still there. And that's the reason that the body starts moving. If we do not overcome microvels, it will remain static. When we overcome microvels, it starts sliding. Have you understood? Hello? Did you understand?
yes, ma'am.
Yes. So what are called microvels, beta? Those irregularities. These are called as microvels, isn't it? And when we overcome, then the body starts moving. If we cannot overcome, then the body remains at that place. It will not move. Got it? This much you have understood between static and sliding?
Yes.
Read better.
Sliding friction is the force that opposes the motion of two surfaces sliding past each other. Sliding friction caused by microwaves constantly breaking and then forming again as the box slides along the floor. To keep the box moving, you must continually apply a force to overcome sliding friction.
Okay. What do we get from this slide is any friction, any friction which keeps the body rolling or moving. There's an opposing force which is friction, and this sliding friction is the friction which is opposing that activity which is called as sliding. So when two bodies are moving past it, like ice skate, ice ski, okay, so it is moving past ice, it is moving further, and the ice is giving a friction that is called as slide friction. How it is caused? Any friction is caused by microwaves. We know that. That the irregularities between the two surfaces called as microwaves. It's not in the book better. But to make you understand nicely, I've used all the slides. So what is happening? When a body is sliding, so these are the microwaves. So this much is over. So it broke this microwaves. Again it will go further. Again will break those microwaves. Again it will go further. Remember that? So what it is doing? It is breaking the microwaves constantly, okay, and again, you know, patching up with the other microwaves, and that's how it moves further. It slides. If it does not break these microwaves, then it will not move. It will remain at that place. Have you understood? It will be a static friction. But as it is able to break those microwaves, the body starts sliding. So it becomes a sliding friction. And what do we have to do? The box should continuously slide. So what we should do? We should apply a force so that the microwaves will be broken. If we don't apply the force, the microwaves will not be broken and the object will come to a standstill or will come to a stop. Have you understood?
Yes.
Yes. So what is required? More force is required for sliding. In static friction, what was that? Alone you were pushing the box. You could not push the box, so it remained at rest. It was static. Then you brought your brother or you brought your friend and started pushing the box. And the box started sliding. That was sliding friction. So the force was more, isn't it? So what you did? You applied more force than friction. Yes or no? So the box started sliding. In the case of static friction, the force that you were giving to the box and the force, that friction force that was applied by the box to your force was equal and the box did not move. Why? Because it could not break the microwave. But in this case of sliding friction, the force that you and your brother or your sister or your friend applied to the box was more than the friction. So it broke the microwaves and the box started sliding. Did you understand nicely? Yes?
Yes.
Okay, fine. Now we come to rolling friction.
Rolling friction.
Just inform me about the time, beta.
Yes, ma'am.
5 minutes, na? Still 5 minutes remaining? We can
Yes.
finish. Okay, beta. Say.
Have you ever seen a car stuck in the snow? Every time the driver steps on the gas, the tires just spin and the car doesn't go anywhere. This is because there isn't enough friction between the slippery ground and the tires. How could you create more friction to get the tires to move the car? Drop sand, gravel, put a board. Put a board under each of the front tires.
Okay. Now we are coming to the third friction, that is rolling friction. As we said, it's a ball, it's a tire, anything which is circular will have rolling friction. The incidents, the event that has been written over here, that has been depicted over here, is you must have seen many cars stuck in the potholes, in the muddy area, that he is speeding up the car, but the car is not moving, but the tire is moving very fast. Have you observed any time? The vehicle is not moving, the car is not moving, but the tire is moving very fast. Have you ever observed? Hello?
Yes, ma'am.
So tire is spinning, tire is moving round and round, but the vehicle is not moving. Why? 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 Because
There isn't
there's not,
enough
yes,
friction.
exactly. There's not much friction between the slippery ground or the muddy ground and the tires. So it's not having the grip, and the tire only moves, but the car is not going ahead. So to make the car move, we have to create friction, isn't it? Make the car move, we have to create more friction so that it will have grip on the floor. How do we do that? So what you will do, it was ice, isn't it? It was icy,
Yes.
friction was zero. So to increase more friction, what I will make it rough. I will make the surface rough. So what you will do? You will drop sand, you will drop some sort of small stones, and you can even put some board, those big boards, it's like cardboards or wooden boards in front of the front tires so that it will become a bit up, and then the other tires will have a grip onto the floor by dropping sand onto the ice. You understand? And the car then can start moving or rolling. Did you understand this? Did you understand better?
Yes, ma'am.
Yes, please read.
The friction between the rolling tires and the ground is called rolling friction. Rolling friction works partly because of microwaves. Rolling friction is much less friction than static or sliding friction. That is why it is easier to use a dolly
It's trolley,
than
beta. It's trolley.
than pushing your little brother in the box.
Now you can see the trolley over here.
Yes.
That's why what we use at the airport, or what we use in any stations, right? And we have got to carry the suitcases that we can have those rollers fit so that it becomes easy for us to use uh, or to cover a large distance without um, using much of force. Easily you can carry those bags, the huge bags with those rollers. This is due to the rolling friction. Okay, because this is the most uh, easy way to carry heavy objects. So now heavy objects that we have taken as your brother in the box. How it will be easy for us to carry without any force will be the rolling friction. Put the box on the trolley and you can carry your brother with the box. You understand? Rather than
Yes.
sliding. Rather than sliding. Sliding was also difficult, remember. Sliding was also difficult. Static, it was also difficult because you were doing alone. Sliding when you took assistance of your brother or sister or your friend. And this becomes the easiest of all, that you take the box and the brother and your brother, the baby, put it on a trolley and you can carry wherever you want, isn't it? So which one is the easiest? Rolling friction is the easiest, right?
Easy. Yes.
Rolling friction is the easiest. So I think you have understood the differences between the static friction, the sliding friction, and the rolling friction, beta.
Yes, ma'am.
So, see, I think this is 1 minute I will take. Which is the first friction, beta? Which is this? Which type of friction is this? Hello?
Yes,
The
ma'am.
force is opposite. Which type of friction is this? Static.
St-
Trying to push. Which friction is this?
Sliding.
Sliding. Very good. Which friction is this?
Rolling.
Rolling. So you understood all the frictions, Shweta? Any
Yes.
problem? Any problem?
No.
So from tomorrow we'll start with, not tomorrow, next week, we start with advantages of friction. Fine. So we come to a close of our session. I think you people have understood as
Yes,
much as
ma'am.
possible. Okay, Vita. Thank you. Thank you for being attentive and have a wonderful day. Always be good to your parents, listen to them, and make them happy. Okay?
Okay, ma'am.